Hi everyone. So this is going to be the third lecture in the series of business analytics course. In this video, I'll be covering of week two and in general a brief description about week two. So this is first week where we start with the numericals and the distribution and how we use them in the business. So if you will see, in this week we will be generally trying to focus on how to find out which kind of distribution is the sample following. So first of all, why do you think we need to guess the distribution, right? We are studying business analytics, so why do we even need to guess the distribution? What is the need here? So the simple example which I can think of is that if you know that your sample is following certain distribution, then you can also infer some uh, information about the population, right, from which the sample is derived. If you remember in statistics, the two courses which you would have done in Stats 1 and Stats 2, uh, we had a concept of descriptive statistics and inferential statistics, right? So, descriptive statistics tells us about the information about the sample which I have taken out. Let's say the mean of sample is this, average height is this, median height is this, etc., about the people. But what if I want to infer some, knowledge? If I want to derive some information about the population from which this data was derived. So what can I do? So there are, with the help of sample, I can infer some information about the data set. Why do we need it? So let's take a simple example. Let's assume, you are a company which, give health insurance. So in general, what is the model? Let's say 100 people come to you and then, you take some premium from them. And if someone has some problem, right, they will come to you and then you will be paying off their, some money to help them in their insurance, right? So that's what you work on, right? So assume if 100 people are coming to you, and how will you tackle this situation if all 100 people come to you for claiming the health insurance? So that would be a big problem because we cannot, the model is like if I am owning this insurance kind of business, I get premium, I take that money, I set aside some amount which, I can give when someone comes for claiming the insurance. The rest of amount I will be investing in somewhere. So that's how banks and all work. No one does it for charity, so don't think it like that. It's a very, these kind of things are deeply studied in actuarial sciences and all. So if someone is from the, actuarial sciences background or maybe in the financial risk market, so you would have studied this thing. We study a lot of survival analysis, right? When will the bulb fail? So these kind of things are very common. So if we can understand why do we, if we can get this information, which distribution is this following? So I can, infer maybe out of 100 people, only 4 people can come in the next month, and maybe 2 people will come in the next to next month. So then I will set aside some corpus which is, relevant for these 4 to 6 people. And then, the rest amount which I'm left, right, with the money which I can invest. So that's how I, as a company, who is, lending, who is giving in health insurance, would make money. That's, the general business idea, not a specific one. But this was just to give us some idea that why this modeling of any kind of distribution will help you. So this was one general idea. So let's just jump into the section. So yeah, as I was saying, what we will be dealing with in this lecture, we will be initially starting with descriptive statistics and then hypothesis testing, basic of hypothesis testing. I won't be, stressing a lot on hypothesis testing because I assume you would carry out some knowledge from your stats 1, stats 2. And then we will come to the important part, which is, guessing the distribution. How do we guess that? So sometimes you will be given some descriptive statistic, like, sample has this mean, this mode, this median, and so and so forth. And then the graphical method, visual method, PP plot, QQ plot, and then we will jump onto the statistical test. We have two statistical tests. Only one is being discussed. So chi-square test of independence is, chi-square goodness of fit is being discussed in this part. However, you can also use KS test, which is basically based on the scientist from USSR, Komolov-Smirnov test. So we have chi-square goodness of fit here for guessing the distribution. So let's just start. So first part is basically descriptive statistics. So in general, if you know mean, median, mode, right? Variance, standard deviation, skewness, kurtosis. These things can give us some information, right, about the distribution which we are going to study. So in general, whenever you see these things, try to guess a distribution. Few general things which I wanted to share, like I hope everyone remembers. Normal distribution would be very widely used, even when you will be studying, linear regression and all. Lot of assumption is based on this normal distribution. So just to give a recap, this bell-shaped curve is called as normal distribution. We write something like this, fancy n, then you will have the mean, and then you will have the standard, variance. So this is how you write your normal distribution. It may be skewed. So what do we mean by skewed? Instead of having a symmetric distribution, you can have something like this. Also, you can have something like this. So, these are called skewed. Why? Because if you look at the tails, these are kind of stretched in one direction. So this is, uh, negatively skewed, this is not skewed, and this is positively skewed. So in whatever direction your tail is more stretched, that is what you call it. So here it's the positive direction, or you can say right skewed. This is left skewed, or the negative skewness. So that is one thing which you should know, the direction of skewness. Also, the mean median mode. How does it happen? So here in this kind of distribution, mean median mode, everything, come at the same point. Here you will have something like this, and here you will have opposite. So, the highest one is the mode, this is the median, and this would be your mean, because a lot of things are stretched in that direction. So you will have median here, and this would be mean. The opposite will happen here. So this skewness is something which you should know where it happens and all. And then another thing, like if you know what is coefficient of variation. So we represented by CV. What is that? Coefficient of variation is basically the ratio between your coefficient of variation is the ratio between your sigma and mu. So this is your standard deviation and this is your mu. And if you remember your standard normal distribution, that was having your mu, which is a mean, as 0, and your standard deviation as 1. So if you will be calculating coefficient of variation for this one, it would be basically 1 by 0. That is, going to be not defined. So maybe if you see, some kind of table where the coefficient of variation given to you is not defined, so then you can take a guess. Yes, it could be, standard normal distribution. So these are just few hints for guessing. Again, mean median mode. Also, if you remember, there is, just one common guessing technique, that if your mean is equals to variance, this is a property of special kind of distribution. I'm taking a 2-minute pause. You also take it a 2-minute pause and tell me which distribution you think of it can happen. So this is, very common for one distribution. Which statistical distribution do you think follows this property, that mean is equal to variance? Okay, I hope you remember this from your stats 2 or stats 1, that, Poisson distribution, basically the parameter is lambda. This has mean is equals to variance. So whenever you see, descriptive statistics table where you will have information to mean, median, mode, etc., etc., this could be a good guess. When you see that mean and variance are same, then very likely it could be a Poisson distribution. Again, these techniques which I'm telling here, coefficient of variation, skewness and all, these are just guesswork. So, you can, when you see these techniques, you get to know in which direction you can think of. These are not accurate test. You cannot say with 100% surety, or with, some 99% confidence that, this is going to happen. So this is some basic thing which you should know, how, mean, median, mode, variance, and skewness and all happen. And then a little bit for your hypothesis testing, which I wanted to cover. So what is hypothesis testing? In statistics, few things you should know, that we collect some sample and then we have some hypothesis. We assume, let's say, uh, population in Lucknow and population in Delhi will have same weight. So maybe we want to compare, the average weight of people, let's say men in two cities. So then you want to compare these things. So you will proceed on in a statistical test. What would be that? You would be basically, your hypothesis would be hypothesis, assumption kind of. So we say null hypothesis. This would be basically average weight in, let's say, city 1 is equals to average weight in, let's say, this is basically your mu city 2. So this is my null hypothesis. What is my alternate hypothesis? I hope you know that just the opposite would be your alternate hypothesis. So why do we do hypothesis testing? It's, it gives us a statistical way to tell something with some percentage of surety. So when you will be collecting some sample, the idea is you can perform some test on those sample, and then using that test, you can, conclude that is your null hypothesis being rejected or it cannot be rejected. So one thing which I wanted to highlight here is that whenever you will be doing hypothesis testing, always remember you can only have two type of results. Those would be H naught rejected. Another would be fail to reject null hypothesis. Right? Uh, at no point of time you can say that I am going to accept null hypothesis. This is a big blunder which people do. So I hope this is very much something you remember. And this is a very common way where people get confused. And I've seen a lot of past year question papers where they will give you some numerical to perform, and in the end there would be one multiple select question. They will give you a lot of options. I think somewhere around 8 to 6 options, and they would be like, accept the null hypothesis, accept the alternate hypothesis, fail to reject alternate hypothesis, this and that. So all type of combination from words would be there. But you need to remember, you can only conclude about null hypothesis, basically your H naught, and you can only reject or fail to reject. You cannot accept. That is not statistically possible. The thing is, you get some hypothesis, and with the help of your test statistic, which you will be getting out, or your p-value, you can only conclude that at this point, I do not have sufficient evidence to reject it. So that is what we say. I fail to reject the null hypothesis. You never say I am accepting the null hypothesis. That is a technically wrong statement. So this is something which people confuse a lot, and I hope you all remember this thing, that you can reject the null hypothesis or you fail to reject null hypothesis. So please remember this thing. Now coming back to few things, which is your QQ plot and your PP plot. So we will just see what is the difference between this. QQ plot is basically quantile quantile. This is probability probability. So one thing which you should know, I'm not going to in much detail explanation, because most of the question which you will see would be theory based. But this is a very interesting thing, like to infer if some distribution being followed is, from a particular hypothetical distribution, right? So if you have some sample, you want to check, is it following normal distribution or not? Is it following Poisson distribution or not? So you can use these plots to check, is it going to be okay or not? So the idea is, we will plot something like this. Here you will have your actual distribution. Here you will have your hypothetical, or you can say assumed distribution. And there would be one line, y equals to x. If your points lie closer to this line, then, the more closer to this line, y equals to x, that means your actual distribution is very much closer to your assumed distribution. Same in this case. The only difference is here we are dealing with quantiles. Here we are dealing with the probability. So here you will have your actual PDF, and here it is going to be the theoretical PDF. So this is what happens in PP plot and QQ plot. You can watch video from StatQuest channel. That is very good. Probably I will try to put it in the description. But yeah, these topic they won't ask you to draw PP plot, QQ plot because you know the mode of examination, but you should know why and when it is used. So quantile, and this is probability. This is basically between actual quantiles and the hypothetical quantiles. So the range would be depending on the your sample, right? But here, because it is between the PDF, so it is going to be between 0 to 1. So this is one thing you should know. And as I said, the closer it is to the line y equals to x, this diagonal, more closer your sample is to the assumed or your theoretical distribution. One thing you should know is QQ plot is sensitive in tails region, basically, and this is going to be sensitive in middle region. So this is few things which everyone should know. So just for an example, if you are basically, this is your normal distribution, and let's say I assume my sample was also following something like this. So if I will, plot this, if I see this thing, they are very much same in the tail region. So that is why QQ plot would be correct. But in the middle region, they are kind of not matching. So in this case, PP plot will flag that, in the middle, they are not very much close to each other. So that is one thing which you should know, that PP plot is sensitive in the middle region and QQ plot is sensitive in the tail region. And I think that is enough for the PP plot and QQ plot to be known what is here. And yeah, so let's jump into the main part, which is chi-square goodness of fit. What is this distribution and all that, what is this test and all. So the idea is we bin the data. We will have, let's say, some sample. Let's say I have some data points P1, P2, P3, Pn, and I assume they are following some kind of distribution. So if you were to check this thing hypothetically, what you would do, you will plot a histogram, right? Something like this. So this is just an example, just assuming if I wanted to check if it was normal distribution, I will plot this kind of histogram, and then I will check, is it, corresponding to this kind of uh, curve, the actual distribution. So it looks very much closer to it. But how do I test this thing in the statistical way, right? In the mathematical way, how I can say that with 95% confidence, yes, it is following this kind of distribution. So in that place, chi-square goodness of fit comes into picture. This is basically a statistical test where we are going to do the comparison. So one thing which you should know definitely is the what is null hypothesis and alternate hypothesis, because there would be questions, right? They will tell you they will give you some sample distribution, binning, how it's to be followed, and then you will calculate test statistic. Your they will give you critical value. Then you will, they will ask you at this critical value, what is the correct option? So you will have something like reject the null hypothesis. That is, these things are distribution sample follows normal distribution. Fail to reject null hypothesis, that sample does not follow normal distribution. So you should know what is the correct null hypothesis. So in case of chi-square goodness of fit, what is going to be our null hypothesis? It is basically sample follows theoretical distribution. This is my null hypothesis. And my H alternative, or you can say alternative hypothesis would be sample does not follow theoretical distribution. So I hope this is clear, that your null hypothesis is sample follows the theoretical distribution. How do we proceed now? So the idea is we make bins. Let's say if you have discrete data, then binning is something very much obvious. But if you are dealing with, continuous kind of data, right? A value can be 60, 60.5, 60.55, 60.99. So in this kind of situation, it is not very clever to have, all the samples as the own bins. We do the binning. So if you have discrete data, then I think binning is very much straightforward. But if you don't have discrete data, if you're dealing with a continuous variable, let's say, I'm dealing with age, right? So age can be 12.5, age can be 18, age can be 21, age can be 23.5. age can be 40, age can be 41. So how do I check, is this, following my normal distribution or not? So the idea would be, I would come down and I would, write my bin. And let's say I'm going with 0 to 18. Then I will have 18 to 30. And then I will have 40 to 60. And probably another bin would be 60 onwards. So these are my bins. What I will do, then I will check my observed frequency. So I will check from my sample how many people come into this. So if I check between 0 to 18, I have only one person here. So that would be one here. Similarly, I also have someone for 18. So this was basically not including. So 18 is included here. So let's check how many people we have between 18 to 30. So 18 is included here, bin 2. 21 is also in the bin 2. 23.5 is also in the bin 2. So we have 3 people in the bin 2. Then I have 40 to 60. Do I have someone in between 40 to 60? Sorry, this would be 30. So let's between 30 to 60. This would be, yes, I have these 2 people. So this would be bin 3. This would be bin 3. So we have 2 people here. So 1, 2, 3, 4, 5, 6, all people done. In 62 onwards, I have no one. So that is how we do the binning. I see my sample. I see which person belongs to which bin. I keep on adding them here. So this is my observed frequency. How do I read it? In my sample, I have one person who is in this range. In my sample, I have 3 people who are in this bin. A bin of what? 18 to 30 age range. So this is something which you should know. For continuous, binning is something which you have to do. So know this thing. And then, you know, we have one column which is known as expected frequency. So how do we calculate this expected frequency? Probably your uh, graded assignment 1 is also based on this thing. So I hope you remember some basic concepts of your stats 2 and all. We will be basically using area under the curve. If you remember, let's say this is my normal distribution. I want to find what is area of my yellow region. This is, let's say, A, and this is, let's say, B. So assuming this is, normal distribution 0, 1, standard normal. So how do I find this thing? If you remember, fz, basically your z function, fza would be this area. Everything before A, this is your fza. And similarly, if I write fzb, that would be everything before my b. So everything in this part, right? So if I subtract these two, basically fzb minus fza, this will give me area of this thing, right? And probability is directly proportional to this. So I get this area, basically this thing, and then I will multiply with my sample size. So I have 1 plus 3 plus 6 plus 2, that means I have 6 people. So let's say I got this probability as 0.4. So this tells me, zero point 0.4 into 6. Let's say this is 0.4 again. So 0.4 into 6. This is 0.1, 0.1 into 6. This would be 0.1 into 6. So this is how you are going to fill your expected frequency. Uh, I'm not going into too much detail here. The more we will solve question, next video would be on PYQs. So that would be more clear. But this is something you should know, that how do we fill your expected frequency. And yeah, that's how you will fill your expected frequency. Now, how do I calculate my chi-square test statistic? How do we do that? So basically, this is going to be summation observed minus expected whole square by expected. So this is something you should know, that we are going to deal with uh, chi-square goodness of fit. So we will have our test statistic like this, where we have observed minus expected whole square by expected. So this is how you find your test statistic. And when do we reject or not? So let's say after doing all this, we get something like x square computed. And then from your table, you will have a standard value, which would be critical. So the idea is, whenever we are doing some kind of hypothesis testing, this is our critical mark. So if something is between this region, we are accepting. If something is outside this thing, we are not going to, accept that thing. That is something not we will avoid. So depending on which kind of test you are doing, maybe you can have two-tailed tests, so you will reject both the regions. Maybe you are doing only one-side test, so you will reject only this region. Maybe you can reject this region. So depending on the type of test, maybe you can refer your stats to formula sheet which they give you. You have different kind of tables, so you can check. So how do we use this computed test statistic and my uh, critical value to reject, or to check if I cannot reject the null hypothesis. So this is something which you should know, that if my tabular value, this thing, or you can say this thing, we can also write this as x square, sorry, chi square tabular, because it comes from the table. So these two are same. If my tabular value is going to be less than my computed value, then we are going to reject the null hypothesis. This is very important, that we are going to reject the null hypothesis. So if my tabular value is going to be less than my computed value, then I'm going to reject the null hypothesis. One thing which is very important, that whenever you will be seeing the table, you will be finding lot of values. So how do we actually find some value from the table? You need two things: finding chi-square tabular. How do we do that? We need two things. One would be alpha and another would be your degree of freedom. So let's discuss two things. What is your degree of freedom? So one thing is, degree of freedom is going to be n minus k minus 1. N is number of wins. 1 is a constant, so not to worry. What is this k? A lot of people confuse this k to be number of parameters in the distribution, right? The theoretical distribution. So if I was assuming this is normal distribution, this age sample which I have is a normal distribution, then someone would say that it is going to be 2, because normal distribution has two parameters, mean and your variance. But this k is basically parameters estimated from sample. So know this thing, that how many parameters you are estimating from the sample, that is going to be here, not the number of distribution, right? So this is something which people confuse a lot. And then we have this thing alpha. So remember this thing, alpha is basically your significance level. Okay. What is significance? This is also 1 minus confidence level. So if I say that, I am 95% confident that my sample is following normal distribution with mu, so let's say mu and some sigma, then 95% is basically my confidence level. Significance level would be 0.05. Why? Because I subtracted 1 and 95% in decimal is 0.95. So this is what you get. Okay, so this is something which you should remember, that alpha is going to be your significance level. Either they will directly give you test the hypothesis at certain alpha, or they will give you some confidence. I want to be 99% confident. In that case, if you are 99% confident, your alpha would be 0.01, right? So this is something very intuitive. Also, this degree of freedom, please remember that this is going to be your parameters estimated from the sample, right? So, right, if I give you this thing, if just say for an example, if I say age of people follow normal distribution with mu 32 and sample variance as 40, or let's say some small value, sample variance as 5. So then you will be basically filling this expected frequency column with respect to the PDF of that. When we will solve the question, we will see a lot of things here and there, uniform distribution, Poisson distribution, exponential distribution. So we will discuss those pattern in detail. But you should remember, if I am the idea for introducing this thing, that parameters estimated, I can give you, to check. Sorry, in the paper, I can ask you, check if sample follows normal distribution with mu is equals to 32 and sigma square is equals to let's say 20. So in this case, because I'm giving you both mu and sigma, you are not estimating anything. Hence, your k in this case would be 0. But if I give you same thing, check if the sample follow normal distribution with mu is equals to 32, but I don't give you sigma square, right? So in this case, you will be estimating this sigma square. Why? Because without estimating this thing, you cannot find your probability. You won't be able to fill your table. Expected frequency, you cannot fill without knowing this probability, right? So for that, you will be first estimating this thing. And when you estimate, your k is 1 because you are only estimating sigma square, not two parameters, which is mu and sigma square. So remember, regardless of how many parameters are in their distribution, k is going to be only number of parameters which you are distributing. This is number of pins, this is number of parameters being estimated from your sample, and this is a constant. So I hope you enjoyed this thing, how we do this thing, testing and all. So this was a basic idea, taking your computer test statistic. There is another way. If your sometimes I hope you know what is p-value. So you can also reject based on your computed test statistic and your tabular value. There is another way to check between p and alpha. So whenever you will be doing your test, if you are running in Python or maybe in your R, so you will see some question like p value. Sorry, there would be some value given to you which is known as p value. What is this p value? I will discuss that in detail. But when do we reject and when do we fail to reject? So if p is less than alpha, reject h naught. And another case would be otherwise fail to reject h naught. So remember this thing very clearly that you are only going to say reject null hypothesis, fail to reject null hypothesis. Under no circumstance you can say alternate hypothesis, anything about alternate hypothesis, or accepting the null hypothesis or alternate. So remember, anytime you see any option which has word accept or alternate hypothesis with respect to this hypothesis testing, you can straight away cancel that option. And when we will be discussing PYQs, we will see a lot of this being discussed there. So yeah, and what is p-value? So I hope we can also discuss that. Let me go down. What is p-value? So p-value is basically probability of observing sample, the given sample, when h naught is true. So this is, I think, a very layman definition. If you will open books, probably you can open any standard book. They have a proper explanation what is p-value. So if I will, get time, I will update this thing. But in general, your p-value is basically probability of observing your sample, maybe something as extreme, because this thing which you see here, this is something extreme value, right? So it can also happen. Let's say I say you have a lot of people enrolled in business analytics. And if I say everyone scores an S, right? And in my sample, I take only people who are very good with their CGPA, right? And then I do the testing. Average grade in business analytics course is S, or you can say, 10 out of 10 in our grading system. So you see that my sample is already biased. I have a lot of talented people. So in that case, probably I can say yes, my alternate hypothesis cannot be rejected. So in that would be a wrong thing. So that is why it is very important to know when what is this p-value. So p-value is kind of giving you an estimate how biased your sample could be, how much the result which you are getting is a matter of chance. So this is something which you should remember, that p-value is going to be probability of observing the sample given null hypothesis is true. Okay, so I hope this is clear. And we will also do some questions in the next video regarding the PYQs. So I hope you like this video.